name reaction. So you can see over here name reaction, and this name reaction is related to your haloalkane and haloarine. Okay, do you know this? I'm just going to explain all with example. Before that, we have done some already reactions. We have distinguished earlier among the various compounds in my previous video. You can see over here, that is here, distinguish between the following pairs, right? So here we have just gone through, okay, distinction between your compounds. Here we have ethyl chloride and vinyl chloride. I'm just going to get one summary regarding my yesterday video. You can see here ethyl chloride and vinyl chloride, and then we have here benzyl bromide and bromobenzene. So what we have done, क्या किए थे हम लोग कि इथाइल क्लोराइड और विनाइल क्लोराइड ये जो दो दिया हुआ था, इसके बारे में हम लोग स्टडी किए थे ऑलरेडी. सो हियर you can see everyone, yeah, everyone here. Okay, so I'll ask question later on. Okay, yes, so here ethyl chloride and vinyl chloride. So we know that one thing, that is in ethyl chloride there is a what sigma bond, but in vinyl chloride you are having a pi bond, and it is somehow it is difficult to break down the double bond because it is having a pi bond, and pi bond won't let to move out the molecule. Here you can see this one, this example, right? Here you are having a double bond, right? Here double bond. So this one is your vinyl bromide. I have just here two things are there here. You can just consider this one, 2 carbon atom, and the pi bond is here, and then is a bromine. So this is what vinyl bromide. Similarly, if I just change this bromine with this green one, so it will be chloride, vinyl chloride. So I have just changed this one, you can see I'm changing, so I'll be having this vinyl chloride. So here it is difficult to break down this this bond, and it will not able to rotate. Why? It will interlock here, it will not able to let rotate it. So here ये rotate नहीं हो पाएगा. Okay, so that it will difficult to break down this one, or it will very difficult to have a reaction because of this pi bond. And this case is not appear in case of ethyl chloride. It is simply a single bond is there, right? So we are just going to do that one. We have already done this one in my previous video. You can see. Okay, so what we have done here, ethyl chloride and vinyl chloride. You can see this is the ethyl chloride, and 2 carbons are there, and sigma bond is there. So this ethyl chloride is going to react with alcoholic, not alcoholic, aqueous KOH. If it will be alcoholic, then this will convert it into alkene, and if it is aqueous KOH, so it will be converted into alcohol. That will give you alcohol. And similarly, here if you are coming, or vinyl chloride, so it will not break down, it will not go for the reaction nucleophilic substitution. Why? Because it is having a double bond, it is having a pi bond, that's why. Okay, so we will go for the another one. and that is here. You can see this benzyl chloride and chlorobenzene, we are going to distinguish it. So here this benzyl chloride is going to react with alkyl chloride. So this alkyl chloride, this one alkyl chloride, so this benzyl chloride can be considered as alkyl chloride. So here RCl is there instead of this one benzene. Here we have CH2, यहाँ पे CH2 है, so that it is what benzyl. तो यहाँ पर जब देखते हैं कि जब ये सोडियम हाइड्रोक्साइड अल्कली के साथ रिएक्शन करता है तो OH जाकर के क्लोरीन को हटा देगा, OH will go and replace chlorine. Okay, it is nucleophile, so it will go and remove chlorine from its position, and this chlorine is going to react with it is going to just associate with sodium, so NaCl will form, and this will convert it into your alcohol. So here we have alcohol, and this alcohol is going further react with silver nitrate. You can see over here silver nitrate, so it will form what? Silver chloride, that is white in color, white PPT will form, and sodium nitrite, and here you have benzyl alcohol you are having. So this is what about benzyl chloride. And chlorobenzene is, this chlorobenzene is not able to show any kind of change. This chlorobenzene will not give you any kind of reaction, it will not going to react with sodium hydroxide. Why? Because of this pi bond, it is connected, this carbon is connected with the pi bond, that's why. So this will create a problem, so it will not go to any kind of reaction. And now we have a chloroform and carbon tetrachloride. So this chloroform, right, this chloroform and carbon tetrachloride, so this will be here, this chloroform can be written in this form. Carbon, it is having Cl and then H. क्लोरोफॉर्म को हम ऐसे लिख सकते हैं. देन कार्बन टेट्राक्लोराइड, सो कार्बन टेट्राक्लोराइड आप CCl4 समझ सकते हो, ये इसको ऐसे लिख सकते हैं, ठीक है. फिर इस कार्बन क्लोरोफॉर्म को रिएक्ट कराया था एनिलीन से, एनिलीन से रिएक्शन कराया इन द प्रेजेंस ऑफ अल्कोहलिक KOH, तो ये रिएक्शन किया और आपको ये जो है फेनाइल आइसोसाइनाइड देता है जो कि पंजेंट कलर का है. ये कार्बाइल अमाइन टेस्ट देता है. क्लोरोफॉर्म जो है कार्बाइल अमाइन टेस्ट देता है, इट गिव्स यू अ कार्बाइल अमाइन टेस्ट. बट इन केस ऑफ कार्बन टेट्राक्लोराइड it will not give you carbyl amine taste. No any kind of pungent smell is coming in case of carbon tetrachloride. So this is the distinction between chloroform and carbon tetrachloride. Once again, chloroform can give you pungent smell because of formation of phenyl isocyanide. Here you can see this one is going to react with chloroform, going to react with aniline, and in the presence of alcoholic KOH. Yes, and now we are coming to chloroethane and bromoethane. So chloroethane and bromoethane, you are seeing that this is having this structure and this structure. This will give you white PPT, this will give you bromoethane will give you yellow PPT, with silver nitrate and dilute HNO3. So here you are seeing that white PPT, we have here white PPT, right, and here we have yellow PPT. Any problem? You can just write it into the comment so that I can go ahead. Yes, you can see this, right. So ethyl chloride going to react with KOH, aqueous KOH, so it will give you alcohol, and KCl, that is further going to react with dilute nitric acid and silver nitrate, that will give you silver chloride and potassium nitrate. This silver chloride is having white PPT. In case of bromoethane, this bromoethane is written in this form. So bromoethane, I can make it in this way, 2 carbon atoms, this is these are the things. I'm just going to create bromoethane, bromo, So this will be bromo, and this molecule, and I have hydrogen, right? So this is going to do, yeah, okay, and we have some hydrogen bonds. Just I'm going to create, yeah. So this is going to connected with this another carbon atom, yeah. Now it is connected. There is one bond required. Okay, here we need a one bond for the bromine, so I'm just giving one bond in bromine. I'll be having this one, yeah. I'm just going to connect this with bromine. This is that. This bromine is here. Now I need to add three more hydrogen here. So this hydrogen, here we have, this one is between these two atoms, so it is having, this carbon is having only two hydrogen atom. This is two hydrogen atom, and on the last we have three hydrogen atom. On the last we have three hydrogen atom. Yeah, okay, and now I can fix over here. This hole is very small. I need another one. Just trying to put it with another one. Let's do it. This may work fine. Yes. Now you can see that this one can rotate easily, right? This one can rotate easily. We can also rotate it easily. No any kind of problem to rotate. But here we cannot rotate. Here we cannot rotate because this will create some problem over here. Okay. So we have already seen that here. So this ethyl bromide is going to react with aqueous QOH. This will give you ethyl alcohol, and that is going to react further with nitric acid, dilute nitric acid, and your silver nitrate. Any problem? No? Yeah. So it will not give you any kind of problem over here. And now okay, we'll move ahead. This one is going to react this ethyl chloride with aqueous QH, so it will be going to react with silver nitrate, and in the presence of dilute nitric acid, that will give you white PPT. And if I'm talking about this one, so this was what ethyl This is what benzyl bromide is going to react with aqueous KOH. So we have here, benzyl, here alcohol, and then KBr, that is going to react with dilute nitric acid, silver nitrate. It will give you yellow color because of formation of silver bromide and potassium nitrate. And okay, so this one is there. And bromobenzene is not going to react with aqueous KOH at all. So this can be your distinction between benzyl bromide and bromobenzene. Okay, so up to we are here, and now we are coming to our point, that is we need to do these reactions. We are going to do it. So let's do it, this reaction. Friedel-Crafts alkylation, first one is that Friedel-Crafts alkylation. So this Friedel-Crafts alkylation is going to react with alkyl halide. Okay, so we'll take one chlorobenzene and alkyl halide, and this one is going to react with in the presence of anhydrous aluminum chloride. Okay, aluminum trichloride, we are going to do reaction in the presence of aluminum trichloride. Let's do it. Here we have, you can see, some carbons is there. Let's do it. So here I'm just going to give one chlorobenzene. So this is what chlorobenzene, this is benzene, and here Cl, chlorobenzene, and this chlorobenzene is going to react with your Rx. So I'm taking Rx as CH3Cl methyl chloride in the presence of aluminum trichloride, anhydrous aluminum trichloride, anhydrous aluminum trichloride. So this will give us what? This methyl chloride. So we are having one AlCl4, and this will form here. Along with, we are having this, that is going to be break down. This alkyl chloride is going to break down, this bond is going to break down, and this methyl is going to be at this para position or ortho position. So we can put this one in para position or ortho position in this way. First here, another is here. First is what? Cl is already there. Either this CH3 methyl will come at ortho position or para position. This is ortho position and this is your para position. Methyl is going to be here. So because of steric hindrance, this will be not considered more. No, the productivity will be more in case of para. Okay, this one. So here we have this is what major product, and this one is your minor product. This is your minor. This ortho position will be minor and this para will be your major. So this is your major product you are having. Okay, because this para formation. So this is your Friedel-Crafts alkylation. ये Friedel-Crafts alkylation है. ओके, अल्काइल क्लोराइड जो है, अल्काइल क्लोराइड आपको रिएक्ट कर रहा है यहाँ से क्लोरोबेंजीन से. सो दिस chloride is going to break down and this chloride will come either with Now ortho or para position. So ortho will give you a steric hindrance, so this will be your minor product and the para will be your major product, right? So this will be your major product. And now we'll go for the Gutterman reaction. We'll check it whether this reaction is what Gutterman reaction is. Having one example, what kind of example is there? Let's look it, let's watch it. Gutterman reaction, we have this one. Gutterman, what happens in Gutterman reaction? Have you heard about Sandmeyer reaction? So this Gutterman reaction is what? A modified form of Sandmeyer reaction. Okay, we have a suppose benzene diazonium chloride, and that benzene diazonium chloride is going to react with HBr in the presence of copper, so that will give you bromobenzene. You know, here nitrogen will just go out, just escape out. Okay, let's first draw the benzene diazonium chloride. So here we have, okay, this one, and then NCl. Okay, so this is what N2Cl we have. I'm just going to do here, you know, this will, if Cl will be there, then right, we have like this one Cl. Okay, one positive sign here, one is negative here. So this one is benzene diazonium chloride, you can see over here, and that is going to react with, you know, HBr in the presence of copper, so you will be having what, this HBr and then copper. So this nitrogen will just escape out from here, and you will be having a bromine here, right? And this copper is going to react with this chlorine. So we have the product is, I'm just going to consider the major product. So you can see this major product here, and there is a one, you know, bromine, and then you have here, you know, copper chloride, and you are having nitrogen. So I'm just considering about this product nitrogen. So you are having a bromobenzene, you can see this bromobenzene is appearing over here, right? Please like, share, subscribe my channel. Yes, the Gutterman reaction is a modified form of Sandmeyer reaction. I'll discuss this Sandmeyer reaction, okay, later on. Okay, so in Gutterman reaction you are seeing that we have a copper in the, okay, and hydrogen bromide, and that is going to react with benzene diazonium chloride, very important reagent it is. Okay, and now we are going to have this one, that is a third one. I'm okay going to explain here. You can see here Urge fitting reaction. Urge fitting reaction. Urge fitting reaction. It is about one kind of fit. Okay, it will just fit here. Okay, one molecule come from here, another molecule come from here, and both are linked to each other. So wedge fitting reaction is there. Here we have, okay, alkyl halide. So I'm taking here suppose ethyl iodide C2H5I, and this one is happening in the presence of dry ether and sodium. Okay, so this is going to do reaction with your benzene iodide in the presence of sodium and dry ether. So that will give you, okay, this will give you thiol benzene. This iodine will come out, and here we have this will move from here, this molecule and this molecule will move from, and we have coupling here in this way, C2H5, and we have sodium iodide, two sodium molecule. We have sodium iodide. Any problem? If you like, you can just hi everyone. Yes, so this is all about your Urich feeding reaction, ethyl iodide and your benzene iodide that is here, and this reaction is happening in the presence of sodium and dry ether. So we have this, and now we are having our Schwarz reaction. Schwarz reaction is related to your fluorine, fluoride ion. So Schwarz reaction is just a preparation of fluoroalkane. So here I am taking one example, that is ethyl chloride C2H5i, C2H5 ethyl chloride C2H5Cl I am taking, and I am taking one reagent, that is mercury, mercury fluoride, mercurous fluoride. We have Hg2F2, and this will be giving you fluoroethane. So this is fluoroethane C2H5F, right? So we have this one, and then mercurous chloride Ag2Cl2, and we can just balance it, right? Here we have two, so this will be balanced over here. No need to worry about it. Schwarz reaction will give you fluoroalkane. So you can see that this is fluoroalkane. Schwarz reaction will give you fluoroalkane. Any problem? No. Okay. Now we are going to have the last one, that is Sandmeyer reaction. This one, Sandmeyer reaction we are going to have. This Sandmeyer reaction is your very important, and from that, this Sandmeyer reaction, we introduce Gutterman reaction, because Gutterman reaction is what, one kind of inherited, it is inherited from Sandmeyer reaction, it is modified form of Sandmeyer reaction. So Sandmeyer reaction, I'm just explaining with an example. You can see, let's do here. Benzene diazonium chloride, benzene diazonium chloride is going to react with copper chloride and HCl. This Cl should be same. Then we have chlorobenzene, and we have nitrogen. So this is what your Sandmeyer reaction. This is example of Sandmeyer reactions. Sandmeyer reaction. If you have any kind of doubt, just you can ask from me in the comment. We have done all. Friedel-Crafts alkylation, Gutterman reaction, Woods fitting reaction, Schwarz reaction, Sandmeyer reaction. Okay, so Friedel-Crafts reaction, what was there? In Friedel-Crafts reaction, we have a methyl chloride that is going to react with chlorobenzene in the presence of anhydrous aluminum chloride. So we are going to have a one, ortho and para product. Para product will be considered as your major product. And okay, ortho will be just neglected. Why? Because it is minor product. Why it is minor? Because steric hindrance played a role over here. And then Gutterman reaction is what, here we have, okay, benzene diazonium chloride, and that is going to react with hydrogen bromide in the presence of copper. So you will be having a bromobenzene, right? Okay, and nitrogen gas. Now Urge fitting reaction is giving you, ethyl iodide and, okay, sodium and, dry ether and your, benzene iodide. So ethyl iodide and benzene iodide is going to react in the presence of sodium and dry ether. That will give you ethyl, benzene. So it is there, we have already gone through. And now, okay, now here we have this, okay, Schwarz reaction is related to your fluoroalkanes, so formation of fluoroalkane or preparation of, okay, fluoroalkane. So here ethyl chloride is going to react with mercurous fluoride, and that will give you fluoroethane and your mercury chloride. Okay, instead of this mercurous chloride, we can use antimony fluoride, silver fluoride, or cobalt fluoride we can use. Okay, and okay, last one is Sandmeyer reaction. This Sandmeyer reaction, last one. So this Sandmeyer reaction is, benzene diazonium chloride and, copper chloride and HCl is going to react with. So on the product side, you will be having chlorobenzene and nitrogen gas. So this was all there, okay, today named reaction related to your haloalkane. And on the last, I want to say thank you to all being with me. And if you have a further doubt or any kind of comment or suggestion, you can just write it to me in the comment box. And please like, share and subscribe, and meet you in the next time. Thank you. Bye bye. Stay safe. Be happy. Thank you.